Thank you very much, Stefan. Good evening to everyone. As Kati and Raini already introduced, I will continue basically on the same topic and explain a bit about what kind of use case we have built to actually give the Data Hub a face, so you can see what's possible with it. And that is my job now. I will walk you through actually what we've built, give you some experiences that we had with the Data Hub, with architecture, implementation details, and also what we've learned from dealing with touristic data. A quick rundown. Our tech stack that we're going to see is in Node.js, and it's a Vue app. The architecture is microservice-based. We use natural language processing. The stage of our implementation is a prototype. So it's not a finished product, but it shows how to interact with the Data Hub and what there is if you aggregate different kinds of data. And days 100 million. It didn't take that many days, but that's how many suggestions. It's just a rough estimate. Probably it's more. I don't know how many suggestions Make My Day can give you what to do in Vienna tomorrow. But before I'm going to jump into the prototype, let me give you a quick rundown of the tourism industry for all those who are not in the tourism industry and are developers like me. I just got into this industry one and a half years ago. I've been a developer and architect in semiconductor and finance industry, and I'd like to explain a few words and vocabularies you might hear so you're not confused. POI or a POI is a place of interest. It's a landmark, a site, a restaurant. That's a place of interest. And in the tourism industry, they don't use the word customer or user like we do in other industries, but it's the guest. So guests are customers or users. Then there is destinations. A destination is a tourist organization, and they market a certain touristic region. They basically have the data. They're interested in data. The data is pictures and text. Pictures are meant to inspire you, to get you to spend your vacation in that destination. The text is basically for search engine optimization. Data is stored in content management systems, and the quality in those systems vary greatly because there's tons of different destinations and organizations in Austria alone. And the people in this industry mostly come from advertising. So they think a lot in campaigns and not so much in products like we are used to. It's a lot about emotions, and those people are a really nice crowd, I have to say. And we had a lot of fun working on that prototype. And let me just jump right in and tell you what we've built. Because basically, I always like to think that we solved my problem. What's my problem? I moved to Vienna a couple of years ago. I didn't grow up here. So I know the city, the usual, the big landmarks. I've seen, the famous places. But every now and then I have friends coming over from Upper Austria, from Salzburg. And they say, you know what? We're coming to Vienna for 2-3 days on the weekend. Let's do something great, right? And now suddenly you're the guide. What happens? Like Joey here, I'm kind of shocked because now it's my responsibility to plan a day, to plan what we're going to do on the weekend. And typically that means I have like 16 browser tabs open, and I'm looking for what to see because we want to see something new, not always the same thing that we already know. Then you need to figure out how is the weather. And if we go there, what do we eat? Opening hours, public transportation, and so on and so on. And to get new ideas, you go online on social media, Instagram, and so on. So this is pretty tedious. And to actually develop a prototype for the Data Hub and to solve my problem, I would like to step you through what we've built to show you that. And afterwards, we look behind the curtain how it's implemented. So the prototype is called Make My Day. And I apologize to everyone who is not German speaking, since it's a prototype. The text here is all in German, but I'm going to walk you through anyway. It's not important. So it starts with a little quiz, and it tells me the weather tomorrow is 2 degrees. Okay. And with answering 5 simple questions, Make My Day is going to make my day for what I can do tomorrow. It's inspiring me. And we're having this little quiz because it asks me about my interests, what I'm up to. It doesn't just ask me, do you want to go to a museum? And it shows me a list of museums, because this filter approach, I think, is fundamentally flawed today, because it does not give you, it cannot inspire you. It can only help you to build a better filter, but a better filter does not allow you to get out of your bubble. So it will never allow you to find something new that you haven't seen before. This is why we are following this approach. So first question, how much time do we have? We have the whole day. That's fine. Second question, are you well on foot? Are you a couch potato? Are you really good on foot? In my case, that's boss level. I don't mind at all. It asks me, what do I feel like? Do you want to, see new things? Do I just want to stroll around? Or do you want to be active outside? I choose active outside. Am I rather interested in, the landmarks, the famous things in Vienna, or the hidden gems that locals visit? In that case, I take the landmarks, the famous stuff in Vienna, because I want to promote Vienna a little bit to you guys too, because it's a really cool city anyway. What kind of restaurants or coffee houses do I like? What kind of style do I like? Some authentic stuff, authentic Viennese, or some hipster cool stuff, or some classy chic stuff? I choose classy chic stuff. So now I've told Make My Day what my interests are, and it uses different heuristics and machine learning technologies to assemble a day for me. And later on, we will go through step by step how that all worked and what it means, what I've chosen. So what happens now is Make My Day is assembling this plan. It is collecting data from the Data Hub, and it should usually be a little bit faster than what's happening now. But since it's a prototype, I'm afraid it might take a little bit longer than usual. But it's ready now, and my plan is being loaded. So what have we found for myself? It says, this is your plan for tomorrow. The weather is 2 degrees, but it's not raining, so that's fine. So it's okay to be outside, I guess. And let's see where we start. So this is now not randomly created, but based on my interest. It's always something different. So this is what I mean with 100 million days. So, and I don't know what we're going to see. So we start out in Café Museum. Opening hours are tomorrow from 8 to 11 o'clock. And now you already see that this is a prototype, because of course it does not concern the lockdown. Now you can't really go out anywhere. And the data that is behind this is not up to date, and it does not reflect the current situation. So that is why a prototype and not the finished product. You see other useful information, like all the different public transportation stops. Whoops. I didn't mean to do that. It shows you where those stops are, but that's not important now. A short description, and basically this is all the useful information. It starts at 9 o'clock, around 45 minutes. And yeah, that's my first stop. And here it says learn more. What I can see here is that actual additional information, user-generated content. In this case, there is a blog article from Secret Vienna. They have a very good blog about things you can see and do in Vienna that are not so well known. But let's move on and see where Make My Day suggests me to go next. It shows me the route, how to get from A to B to my next stop. And the next stop is at 10 a.m. and it's a walk through Augarten. It's pretty cool. Augarten is a park in Vienna, pretty large park, inner city park. And we have a plugin here that shows me the route actually. So it's a walk for like an hour or something, 45 minutes. And actually here I could, find the link to actually buy a guide. And let's move on. So it's about 11:15. It suggests Alte Donau. Let's see what else it is found. Okay, so there's more stuff. So we have blog article from A-List, which is an Alte Donau, which is basically a lake in Vienna, you could say. It's a part of the Danube that has been dammed up, so it's basically a lake. And there's an article from Vienna Info. We have a YouTube video from Vienna Info. It's pretty cool. You can see what's going on there. There's a fun fact. There's 3.7 million cubic meters of water. So I guess that's a lot. So all this sort of information that we've collected here from various data sources should give you a different perspective on this common touristic data, because we are all used to seeing those glossy, images. But to make it really authentic and interesting and inspire me to actually go there, I want to see what other people have experienced. I want to see people and stories. What have we here? For instance, in the afternoon, we're going to Tiergarten Schönbrunn. That's the zoo in Schönbrunn, for instance. Pretty cool. We have a few more videos here about Schönbrunn, which is close by. So the palace is close by the zoo, and so on. And this is how these day plans are created. And in the evening, we go to Café Imperial. Nice. If I don't like it, I just say, show me something similar. Show me something else. Maybe I've seen this already. So it suggests me a different coffee shop. Not bad. Oh, well. So this is Make My Day. So it has planned my day. And the important thing about it is that this is not a blog where I read something and I'm not sure if I can actually do it or not. This plan is made in such a way that I can walk out, put on my boots and do it, because it takes care of the opening hours, right? It takes care of public transportation. It takes care of the weather, and so on and so on. So it really, in a sense, is like a ready-made solution. I do not need to build the day myself, but it already suggests that plan for me. All right, so let me move back to my presentation and see what's actually behind the curtain. So what is Make My Day from a developer's perspective? In short, it's a web application that is built in Vue, so it's built in JavaScript. The architecture is based on microservices. So there's a lot of stateless microservices behind where the plans are created, where the data comes from. It uses an AI. It uses AI technologies. I shouldn't say it uses AI. There's no such thing. There's just AI technologies and algorithms. And it's a recommender system that mostly uses natural language processing to actually classify data and to connect those storytelling data with those point of interest data. And another big part is it's a data aggregation pipeline, because all this structured and unstructured data needs to come from somewhere. And basically the approach is similar, like what you guys from data warehousing might know: extract, transform, load. So these 4 topics I will talk about in the next few minutes. First off, let me give you a bird's eye view of Make My Day and the Data Hub. And I've done it in a specific way how I personally think software architecture should be communicated. So if you are a developer or an architect or in an architect role, I can highly recommend the so-called C4 model by Simon Brown. I've used it a lot in my old teams before, and it's a really very simple and concise way that forces you to think about actual software architecture, not just boxes and lines. On a top level, we see that Make My Day is a software system, and guests use the software system, just like I did now. I create and browse plans. Make My Day, the software system, uses the Data Hub. And as you see here is what Georg has explained so well before, that I have a single point of contact. I, as a developer, as Staymate, I talk to the Data Hub, and I don't need to talk to, there's many other systems like Tourdata, the ZAMG, it's the Austrian National Weather Service. Then we have another company that is planning tours and traffic routing. And of course, there's tons of blogs and websites. And so this really shows the benefit that I have when I implement it, because I think those guys wouldn't even pick up the phone if I would call them here on the right side. So this is much easier because I have only one point of contact. And now let's step inside this and this software system. What I mean in this and this software system. So on the left-hand side, we have Make My Day. And this software system consists of a client. Basically, it's the browser, an application in Vue.js. and we have a server side, which is an Express app. And as you have seen before, the client loads the quiz, executes the quiz, and the interest created from that quiz, it's a vector basically, it's an interest vector, a feature vector, is sent to the Make My Day app. And this Make My Day app on the server side creates the plan. We will see in a minute how it does that. But to do that, it uses microservice from the Data Hub. And now we see closer what the Data Hub actually abstracts from me, because I, plain vanilla REST JSON communication with Data Hub, it abstracts like some SOAP XML interfaces from one of those content management systems, touristic content management systems back there. And it abstracts probably, Meteo data in FTP format, all this kind of complicated stuff I don't need to worry about, because the Data Hub either forwards these calls directly, or maybe it builds a backend service that, actually allows data providers who are not really, maybe it's not their core business, to offer an API service, but to share their data and have someone else implement an API service. But from my perspective, the real benefit and the innovation in this picture is that I am not only using the Data Hub, I can also provide a service to it. So that means I, as Staymate, as my startup, I can share a service for others to use. And in this case, I'm using it myself, of course. But this is really a huge benefit, and this separates the Data Hub from other content management systems that simply aggregate a lot of data. Because here you really have a platform where different kind of parties can come together and provide services, not just data. What I've said before here in a bit more detail, client side of Make My Day is very simple. There is a few REST calls, basically CRUD operation to create and edit plans. And you can also embed UI plugins. We've seen the routing plugin before, and also this hiking map. So it's something as a front-end developer you can right away use. We'll look at the mechanism afterwards. On the server side, it's an Express app that queries the Data Hub and provides services to the Data Hub. Here you just see a few of the interface. You post a plan, you get the plans, you put an alternative, like when you switch a restaurant or stuff, you get the quiz and you get the weather. So on the server side, I would like to go into a bit more detail about a few services, especially the location aggregation service that Georg has mentioned already before, which is hosted by IBM, and Make My Day uses this service. And two other services that we have provided ourselves. And I will explain that in detail, how actually the data beneath it looks like. So the location aggregation service is shown here plainly in the developer portal. You guys all know how a REST call works and how JSON looks like. But basically, you can use this to get the details of a POI, of a place of interest. And what you do then is you take this data and you can incorporate it in your application, either server side or client side, or do whatever you need to do with it. But the important thing here, the location aggregation service, as Georg mentioned, is it's opinionated. It is application agnostic, but not domain agnostic. It favors places of interest. So like in a NoSQL data structure, a NoSQL database, where you have a document-oriented structure, the place of interest is the root of all other data. So when you query one location, one place of interest, you immediately get all the traffic lights, the traffic stops close by. It tells you what the weather there is for the next couple of days. It gives you tons of other data that usually is spread out in different services. You could get these individually, but it's much easier if it's already aggregated into one place of interest. And this is the location aggregation service. Why is this easier? Because it saves me mapping all those different IDs from different systems together to build this unified view of a point of interest. And second service I would like to show is the Staymate Directions API. So this is a service that we have provided into the Data Hub. Basically, this is the plugin you've seen earlier showing the route from A to B. The same technology we use also for showing the hiking maps. And what we've used here is OEmbed. It's I don't think it's a standard, it's a quasi-standard basically of how you embed resources into your web page. So this is mainly focused on front-end developers. So you can turn a URL into something like this. How you do this? You call this OEmbed endpoint, the directions endpoint. And what you get back is, as you see here, a JSON response, and it contains a snippet of HTML. And this snippet of HTML, along with a script that is embedded here, is actually downloaded in your browser, in your HTML page. And when it executes, it actually renders everything you have in here. So this is basically an easy way for front-end developers to get plugins into their web page. So the Data Hub is not only for backend server-side programming, but startups like us can also offer plugins that are easily embeddable into content management systems like WordPress and so on. So you don't need to build everything yourself. You just need to make this one call, and you're able to use plugins. The same thing we've done for Freitag and Bern tours. I'm not going into detail here. If you're interested, press F12 on the browser. You see the calls, you see what comes back and how this is actually rendered. Whew. So that was a lot. Get a glass of water and consider the design, what we've done here, especially in respect to the location aggregation service and OEmbed. So when we've built this and when we started to actually host our own services and consume our own services, we've reached a stage where we were eating our own dog food. And in my experience as an architect, if you build a system that is referring to itself and consuming, if you consume your own stuff, that's typically a good sign. That means your architecture is good and you've built something valuable. Because if you don't use your own stuff, you should question if somebody else can use it. So I think this has proven that this is useful, what we've built. As I mentioned before, the location aggregation service is opinionated. The design decision here is that you get all the POI data in one call, which makes it simply easier to use. Of course, you could make 10 different calls too and match all these individual snippets together in one resource that is useful for you. But we believe it's much easier if you provide this service already for the Data Hub. Since we are in the tourism industry, I think it's fair to assume that we have a certain approach how we view data, and the places of interest are a very useful concept to structure your view of the world in that way. And yeah, anything is a resource. So even if you don't think about it, but in my opinion, and I'll debate you on that, is that routes, for instance, how to get from A to B at that time is just another resource. You say, embed me a route from A to B at that time. And the resource is specified by query parameters. So I think this is a default way how you can offer plugin and embed functionality. And I think Enter and Go has used the same approach as well. So this seems to work pretty well. But now let's move on. How do we actually plan a day? And I like to call it, how do we dress a skeleton? Because the way we plan the actual day, the way how we assemble the individual POIs sequentially, is not by filling in a template, but it's the other way around. We are dressing a skeleton. What I mean by that is we have an idea how a day should look like. You know, typically in the morning you have breakfast, you're gonna have lunch sometime if you spend the whole day, and maybe you're gonna have, you know, dinner in the evening, something like that. So your day has much more, it has a structure. And if we have a basic skeleton of a day, it's much easier for us to build a meaningful day out of that, based and fill it with interest. Like you can consider the skeleton like a rough plan. I'll show you later on. And we put clothes on it. You know, every point of interest that we add we add onto the skeleton, and depending on what kind of how far we are with the dressing, we will make sure that the follow-up place of interest matches. So if you're wearing a tie, I'm not going to match it with bathing trunks or something like that. And it sounds complicated, and it's actually, if you consider it, not too complicated, but let me go through it. 10 simple steps. First step is we execute a quiz and we get a feature vector of interest. So this feature vector consists of certain topics, like you're into outdoors, fine dining, culture, museum, and so on. Based on that, we have a pool, a closet of skeletons, I should say. We have a closet of skeletons, like by design, and we pick the skeleton that matches your interests the best. For instance, a whole day skeleton. After that, we fetch a lot of places of interest nearby, basically all of Vienna. Then we classify those places of interest depending on what your preferences are. Do you like a chic place, or you like a hipster coffee house? Do you want to see landmarks, or do you want to see hidden gems? Then we take those points and we build topics out of them. And a topic is not a category of a place of interest, so it's not museums, galleries, yeah? But a topic is, for instance, culture or arts. And in that topic, we might have different categories of places of interest. Like culture might contain a museum, a gallery, some exhibition, and so on. Then we sort these topics and poise based on their similarity to our interest vector. We throw away bad poise that lack data quality, like bad pictures, no text, this kind of stuff. And after that, we incrementally dress the skeleton. We take the empty skeleton of a plan and we pick the best matching topic, and from that topic we pick the best matching place of interest. And we do that over and over again until the plan is full. So what do you mean by pick a place of interest? When we pick one, we make sure that it's not too far away. It doesn't take too long. Does it take too long? Drop it, take the next one, and so on. And we do this for like 20 plans, and after that we have a global heuristic that looks at the plan as a whole and chooses the best matching plan. We select a winner. After that, we add storytelling data and we send it back to the client and display it in the browser. So what are the places of interest in that algorithm? On the right-hand side, you see the skeleton here. So this is a simple JSON model, and it has a few cornerstones in there. It says, okay, we're gonna have at 9 o'clock, try to find a coffee house. And since this is a plan for nature lovers and people who want to be active, try to fit in a hike and try to fit in a lunch break at 12 and so on. So this is the empty skeleton of a plan, and during the algorithm, this gets bigger, and aggregated with lots of poise. And one design decision we've taken here is that we are modeling. And modeling for us is knowledge by design. So as I mentioned earlier, we have a certain idea of how a plan looks like, and we express this in a model. What else could you do? You could simply, try to develop some AI that you just throw in anything and it chooses whether the plan is good or bad. So this is a reinforcement learning approach, but that's the same as saying, yeah, your problem is really hard. So we start in our prototype with something that we can control better and see immediate results. One design decision is that we match skeletons and places of interest. And we use feature vectors and cosine distance to find what's similar, what's not. This makes sure that in our algorithm, we don't have any categories or places of interest hard-coded. And that means it's easy to switch those, and the logic is still the same. And as I mentioned earlier, the strategy we're following is a procedural one and weak AI, very narrow AI. That means we classify POIs, we compare them with skeletons. We don't have an overall global approach where we throw data in and train some huge neural net to decide whether this is a good plan or not, because it wouldn't be explainable and it would be very difficult, I think, to come up with something meaningful fast. and nobody knows whether the data is actually sufficient to learn what a reasonable day for a human is, right? So that is why we support it with modeling, and we have a procedural approach and weak AI. Let me just talk quickly about the classification we're doing. In the quiz, we've been asking about how the weather is, what kind of atmosphere you like, and do you want to see famous landmarks or not. There's two tasks. One is a labeled classification, a supervised classification, where we use basically logistic regression to classify labeled data to find out whether a place of interest is good, whether it's raining or not, and to classify the atmosphere of a place, whether it's authentic, hip, or classy. The problem here is, I'll get to that in a second, there is a large human bias. It, of course, depends a lot on how you label that data. Let me get to that. And the other part is unlabeled. Basically, how do we find out whether something is famous or not famous? It's very simple. We're inspired by Google's PageRank algorithm. If certain places of interest are mentioned a lot in other places of interest in descriptions, then they are probably very famous. If stuff is not mentioned that often, then it's usually a hidden gem. So this is how we classify the places of interest during building the plan. Classification with logistic regression. This is what we have done, for instance, with weather and the atmosphere of a place. Very simple approach. We've done it in TensorFlow.js because we could stick with our tech stack in Node.js. As features, we use categories and text. Of course, we pre-process them. And as you can see here, we build like input vectors, which are very sparsely located, which are very sparsely encoded. And we use logistic regression in TensorFlow. That means it's a fully connected layer, cross entropy loss, and softmax activation. Basically, multinomial logistic regression. And with a simple setup, I mean, this is one of our prototypes we just started out. You see that it converges fast. It's not really big and complicated, and the confusion matrix is fine. So that means there is something in the data that works well, and you can even build better models on top of it. So, but let me get back to what is good or bad weather anyway. You see here, we have a few places of interest, and these are the labels. In this case, everything is fine, even if it's raining. And so you have people labeling this. In our case, it was a bunch of people we asked to do that. And what happens is you always have these people. So there's always someone who will argue about what is good weather or bad weather. And actually, they're right, because it's very difficult to say. If you don't have a specific persona in mind, it's almost impossible to say if something is okay when it's raining or not. Especially when we see the prediction here. This is one example of a Heuriger. This is a wine place, winemaker's place. And the people who have labeled that, and I'm among those people, they would never go to such a place if it's raining, because I wouldn't think of it. But later on, I talked to one of my other co-founders, and he said, what? Of course you can go there. They're always open if it's raining. You don't need to sit outside, and so on. So yeah, depending on where you get your labels matters a lot, of course. But once you get into it, you really see that classifying something as good or bad weather is difficult if you don't have a specific persona in mind, right? If it's for anyone, it's hard to say. Another problem is that we've discovered, of course, is that sometimes there's little data. In this case, this is classified as a miscellaneous gastronomy. There's basically no description text. It just says second floor. And you can see here that the net, it decided okay, but is super confused actually. 76 to 23 with this kind of activation function is actually pretty confused already. So these are the things that you have to take into account when you work with touristic data. Opinionated people and data quality varies a lot. All the storytelling content that I've shown you earlier, like videos, blog posts, stories, social media posts, are all from curated data sources. That means those posts, the individual posts, are not, linked manually, but we've chosen certain data sources that provide good quality because they have good content, basically. and we read their content and match it with places of interest to enrich them. And let me show you how we get that. So we have a very simple, not simple, but common data aggregation pipeline. Like data warehouse people use ETL, extract, transform, load. We do something similar. We use retrieve, recommend, aggregate. So these are our 3 stages where we get structured and unstructured data from all kinds of different sources, and we get it to us locally. Once it's here, we let our classification engines and our recommender engines run on it and classify it and link it to places of interest that we already know. And once we have that link, we aggregate it into our database, and then we can host it on in our Staymate API, which is the Stories and Facts API, and then we can provide it again. If you look a little bit closer how technically it's implemented, as you can see here, we have this aggregation stage, and we have different modules for different kind of data sources, because they all have a different API, of course. And in Node.js, you're kind of spoiled because there's a ton of NPMs you can use and to read all kind of data. So that's pretty easy in Node.js. Recommendation, natural language processing. I'll talk about that in a minute. Not that easy in Node.js. And once we have classified stuff, we aggregate it into our database. And in this case, we do so as structured data according to schema.org. So that helps us a lot to actually not just have a database, but have a knowledge graph, which allows you to build much more smart applications on top of it. So that is our data pipeline. This is where the data comes from. And now let's look at how do we match this data? How do we recommend? So in the background, it's not important. We see a ton of text, and this is the text that accompanies a YouTube video from Wien Tourismus, for instance. And this is how the recommendation stage works. First off, we derive features. We take all the places of interest and build features based on the text. Typically, this includes metadata categories that are already there, but mainly bigrams, because it's simple and it works pretty well. Because a bigram in touristic data is, I call it a poor man's named entity recognition. For instance, Kunsthistorische Museum is a bigram, and it's also the name of something. So if you compare bigrams in different data sets, you will find a lot of links, named entities referring to each other. Very simple approach. Then we featureize the data we have in our database. We featureize the video data sets. So we have 2 sets of feature vectors. In the next step, we match them against each other with cosine similarity. We find links between them. And once we have those links, we transform it into creative works. That is a data structure used in schema.org. And these descriptors we can store in the database. This is an example how it would look like. So this is again a creative work in schema.org. You have here the ID of the place of interest in the database. This is the social media post, the YouTube post that we have matched. And we have an explanation here, what matched and why it matched. So it could be a name, a bigram in this case. It could also be a street name and so on. So there's different kinds of matches that you can find. And explainability is always important to find out how your system behaves, actually, what happened. Again, a quick look at learnings and design considerations about this AI stage. Of course, data matters. Look at your data. In tourism, there's a lot of semi-structured data with very varying quality. But if you look at the data in particular, you'll find certain patterns or tricks that you can use to get a lot of mileage, I would say, with without building a rocket ship. Let me put it that way. We've used a modular approach, how we build our algorithm. So we use a model-based approach and really narrow AI for very specific tasks, but on a local scale and not on a global scale when we build the plan. Since it's a prototype, we stick to a very simple tech stack, which is basically JavaScript and Node.js. And this brings me to NLP Node.js. Well, be prepared to struggle a bit. It's nothing like Spacey, NLTK, or anything in Python. There is a few libraries you can use, but let me explain in one picture. You see this code snippet here, and you see what I've done here? Yeah, I've written my own escaper. because what happens that the library is not really written for the German language people. So if you have umlauts, it doesn't, it can handle umlauts. Yeah. So that gives you a good idea of the state of NLP Node.js. You can use it, but know how far you will get. What happened in the meanwhile after we've built this prototype? I would say the inevitable happened. If you give developers and architects enough time, they will turn anything they build into a framework. And we've done just that. We have added a layer and turned it into a framework. What does that mean? As you see here, we have a very rough layered architecture overview. So we have the UI layer, which is what you've seen in the browser. We have the core layer where we do all the planning and the ML. And we have the data layer where we extract all that data. And these two layers we've pulled out into a framework with hotspots where you can plug in different data modules for different data sources. And you can plug in different behavior, like how it plans the day and what kind of plans it creates. And we've added this layer so it's easier for you to plug another UI on it, because what we've done is in the browser directly, but you might incorporate it into an app or into some other application with a different UI. So UI is typically not reusable. So core and data and these hotspots are in a framework. Yeah, it's a nice framework, but why did we do this? We've done this because what we built now is for Vienna, but we will be very interested to see how we can use this approach in Salzburg, in Tyrol, in Vorarlberg. That means in the holiday destinations. And holiday destinations are different, of course. There's different places of interest, different activities, and so on. Like if you go on a summer vacation, you typically spend like 6-7 days there, and not just one day. So it doesn't make sense to make a suggestion for one day, I guess, but maybe for the whole week. What can I do in this week? What can I do in my vacation? And there's different data sources. So all these things that are variable, we try to externalize and make it pluggable. So we can reuse this prototype and build an application out of it that is really productive. And of course, we also want to use it in our main product because our startup builds digital concierges for hotels. And of course, it's also important for us to reuse what we built as part of this prototype also in our core product. And this brings me to the end of my talk. Thank you very much.